Hi friends, Chris Leyenbauer here, founder of FazeDoc, this time with the sound on. Welcome to the April edition of FazeDoc Live. We're excited to have you join us. If you're new to FazeDoc, we're a manufacturing startup in Raleigh, North Carolina. We focus on systems to mount, organize, protect, and transport single board computers and microcontrollers, so we really inhabit the mechanical side of projects more than the electronics side. Our featured guest today is our good friend Steve Friedl, aka Unix Wiz. Steve is a Southern California software and network security consultant, a community hike leader, and an unabashed fan of FazeDoc products for prototyping. He's been using our products to develop and prototype automated production equipment in his brother's medical manufacturing facility in Southern California. So we invited him to share what he's been up to. It's really pretty amazing. Hello, Steve. Welcome. Would you just tell us a little bit about yourself and about your brother's operation and how we got to this point?
Well, good morning, Chris and Barbara. I'm so happy to be here. I'm at the production facility of Resolution Biomedical in Tustin, California, thankfully 2 miles from where I happen to live. And we make COVID test collection vials. So these have a couple of milliliters of fluid. We take these from empty vial, fill, cap, label, package, inspect, and ship. We've probably done on the order of 3 million vials in the last year. Resolution Biomedical was started by my brother, I don't know, a decade or so ago for doing cell cytology for a different kind of testing, but pivoted when COVID came around, and it's been a really fun time. I got enrolled to kind of help ramp up the production, so we built some hardware, built some software, work with a lot of the smart people here, and we've made a really nice little product.
Well,
So,
but your background isn't really mechanical engineering, is it?
no, not so much. I have a degree in math and computer science. All of the work that I'm doing with electronics and anything mechanical is strictly amateur. I've been playing with electronics since I was in the 6th grade, but I'm still really an amateur at it. I'm getting better though.
Well, I would say that you're fearless having seen what you've done, and honestly, that counts for a lot, just diving in
A little
and
bit,
persisting, right?
right. So I guess the first thing I'm going to do is maybe kind of show the general production process of how we make one of these. Do a quick little drive-by. I'm thankful to have production shift leader Mike here helping me out behind the camera. He's got a way better eye for this stuff than I do. When we're producing these vials, I'm going to do a quick run through and then come back and revisit our filler bot. We load up a stack of empty vials. I will mention everything we're doing that you see here today. None of this is going into actual product. This is all for demo purposes.
Right.
Everything we're doing is going to go through rework and sanitization. Normally masks and gloves, but we're only 2 people here, and that wasn't necessary to do any of that for today. So nothing here is going into a real product. All right, so we start by filling this up. This will get thrown in here. This will fill up the vials. We'll come down to the next station. We do a little quick finger tight capping of each little vial. Then to the capping station, we'll spin around a little bit. Kind of a little torquing, pneumatic torquing. Then to this wonderful device that was built for us by Roser Products around the corner in Chino. This takes a feed of the vials, prints a label, wraps the label on, kicks it on out into the tub. After that, it goes into packaging, inspection, and then shipment. We've done, I think I said, around 3 million vials. So that's kind of the general flow. There's multiple capping stations. People work in various spots. But mainly we're here to start seeing about the filler bot. So
Yeah.
I'm going to walk over that way.
And as you do that, Steve, just as the pandemic hit, really to get to the quantity of production that you're doing now, you guys pretty much let the clutch out overnight almost, didn't you? I mean, it was a really fast ramp up, wasn't it?
It really was. It was quite a pivot. And when we realized that our our particular preservative that we use for the other process would work fine. Here, we had people who know how to do this, do all the proper validations. So we were basically ramping up production in a different building while this suite was being built out, while I was building the filler bot. I guess this is as good a place to start as any.
Sure.
This is Millard for Millard Fillmore.
Of course.
It's actually based on this XY plotter mechanism that I bought from eBay. But the idea is that the head kind of moves around to take a physical pen and move. I built all of this around it to have some nozzles. I think you can see that. We have 3 filler nozzles here. I'm going to see if I can actually start this. I think I set this up properly. We have, hang on, let me see if, well, I'm sorry, I didn't check this in advance. I should have done that.
That's okay. This is, oh, there you
Here
go.
we go.
Outstanding.
So this one is doing 3 nozzles at a time. You can see that it just moves right along. It's completely unattended while it runs. Mike, you can focus over here on the pumps. We use these wonderful pumps from New Era Pump Systems. They are peristaltic pumps that kind of squeeze the fluid through the tube so the pump itself doesn't actually touch the fluid.
Right, completely sterile.
Everything is lot numbered everywhere, and we pay a lot of attention to that. So it is now filled 72 vials.
That was beautiful.
This works really well. An obvious question is, so what's the deal about the 3? And the reason is the XY mechanism simply doesn't have the full range to fill this whole tray.
Right.
We are working on, I'm working on a new version, the FillerBot Universal, that'll cover the whole range. We really optimized for doing 3 nozzles. That seemed to work out really well for us, because it also divides into the geometry of the tray. The base, I'm going to scoot on the other side here. Actually, Mike, I want to show the phase dock, which is in the back. This is the guy that runs everything. I have a little beagle bone here, a little controller, some glue logic, a couple of serial ports. The pumps all talk serial, so does the plotter. There's actually stuff coming up to the front panel. And a laptop is because I haven't got the start button running yet. That's going to be on the next version.
Okay.
This has been super reliable. It actually fits perfectly into this spot. I don't know why I don't have that bolt in there. But this is actually the final production version. It's not a prototype. We actually do keep the clear plastic cover on it normally, just to keep it protected. And this has been unbelievably reliable. So I love how it looks nice. And this has been way more reliable than it deserves to have been.
Yeah, and actually, just as a side note, even with the 3D printed clicks and slides that we have, they have been more reliable over time than I expected them to be. So it's good to see some validation from out in the field.
This has worked. It's really worked well, and the fact that the whole thing just runs and runs and runs has been great. As we move on down the production line, I have more or less to do with the various parts. What I'm going to probably do is trade places with Mike and have him cap and do a cap. Let me see if we can do this. Cap and fill a few. So just a handful of them. Right now he's using a little piece of plastic that holds them apart. There we go. And those are 3D printed as well. So it holds them firm so you can put the cap on finger tight really easily.
Right.
So just do 2 rows is plenty. So we just have a tray. And again, these are all rework parts. None of these are going into production. Unfortunately, this is a manual operation, and we haven't really figured out how to automate it yet. But we have a really, really good factory crew here that just goes to town, and this place just runs and runs and runs and runs.
So staging the caps on the vials is the part that you like to improve right there, right?
Right. Yeah, that's plenty.
Yeah.
So then so then normally we would do them all, but now he's going to go and actually run the cappers. Just let him run anyway. Yeah, Mike, he's done a lot of capping here. He's not supervising.
Oh, so you've got an automated process there as well, huh?
Right. I think
Semi-automated.
that I'm not sure if I turned the pump on soon enough. The compressor, this torques it down to a certain exact torque that's required for reliable filling.
Right.
And I think that I didn't do it soon enough, so I think we're running on a little bit low pressure this morning. But you get the idea.
Oh yeah, absolutely. Yeah.
All right, so he's just doing a handful of those. That's really good. All right, Mike, now we'll swap places here. We come over here to the Roser labeler. We have two of these. These are really wonderful pieces of engineering. We love these guys. They look really complicated, and it is just in places that you didn't even know it had places. But labels feed from the far end, feed through the video jet printer. The little paper path comes up and around and feeds the collect over there. This is all kinds of moving parts with so many adjustments. The wheel right here, this is the pocket wheel, and we can see that it holds 8 going around in a circle. The place where phase duct came in was a little bit later. When we ordered this without really any input mechanism, so I had to design this whole input mechanism here.
Oh, how you feed the vials to the machine, right? Stage them and feed
the
them.
vials to
Okay.
the machine.
All right.
When we got it as ordered, there was just this little plate, so you would manually feed 3 at a time or something. It was miserable.
Okay.
So we were lucky. A good friend of mine is a real mechanical engineer, and he helped us with this a lot. But everything, this is 3D printed. Everything white is this. Even this piece is here. If you have a tray of vials that need to be capped and you're keeping it here, this keeps it from blocking the path. So it's something that you learn by kind of fooling around with it for a while. But where phase duct comes in, this sensor here is what detects that a vial shows up and says go.
Right.
And it drives the process. But sometimes you need to stop it. Now, obviously, we have over here the big red one, the big button, and that kills the power on everything.
Right.
Sometimes that's overkill if you just want to pause the actual flow. So what I built is this box down here that sits between the sensor and the controller.
I see.
So it intercepts that signal that detects it, and you can look down right here, Mike. Red means that we're in a pause mode. If I hit green, now that sensor is going to go to there. So let's let it run.
Wow. Wow, that's fast.
All right, so I just hit the pause button.
And you paused
This
it. Yep.
thing can do about 80 vials a minute when it gets cranking.
Wow.
It's really quite a thing to see a skilled operator load these input trays up. It's really amazing. They're way faster than me. But this has really helped us. One of the things that it comes up, Michael, you can show those labels are about to run out over there, right? Yes. So when those run out, you obviously has to put a new roll of labels on. The way I used to do it is, when it runs out, you just put on a new roll, and it takes about 10 minutes to fully rethread the machine.
Yeah.
Well, our production supervisor, Marisol, figured out that you can actually splice a new roll onto the end of the old one and not have to go through that whole 10-minute thing. That's where this comes in. If I'm watching that, I
As
can
you
tell it to
see,
stop.
yes,
I'm
right.
not worried about having to hold this back by hand because we're always, sticking a thing in the way or blocking it. Now you just hit the red stop button and it's not going to go anywhere. But what it's also got, the yellow button is the Uno button.
Oh,
one to go
yeah.
through. So if I'm watching the labels, I say Uno, it'll do one, but no more. So you can single step until, okay, now it's at the end and we can rethread it or whatever.
Well,
So this,
a couple of
ahead.
observations, Steve. Just the continuous improvement that I see there, and not only that, but the input from all your team members. So I just want to give a shout out to those two concepts because I'm a big believer in both of those things. And I think the third thing I'm seeing there is not only do you have much more granular control over that machine now, but everything described is a lot safer than it was by manual intervention, isn't it?
I believe it's safer, and it's certainly faster because if you kill the power, it shuts everything down, and
Yeah,
that's just no fun. Occasionally, the machine does skip a label or something gums, but so Chris, we had talked about this before the camera went live, and you had asked about how do you come up with ideas for improvements? And the main answer is I have sat at this machine and run full shifts myself,
right,
tens of thousands of vials.
right.
So if I'm sitting here running the machine, I'm learning what the sounds are like and say, okay, something's different. I don't know what it is, but something doesn't sound right. So then I'm able to talk with the other experienced operators and find out what that means, and then get the idea for the start and stop and pause and the single step. The thing where phase ducts comes in, obviously this is not phase duct. There's a little printed circuit board in there that I laid out and designed.
Right.
I'm going to scoot over here to the phase duct. This is that same circuit.
I
I
see.
laid this out on this for testing. Get the vials out of the way, and it simulates all of the inputs. So stop, go, uno, and then a fault button. I'm actually going to wire up an input to the real device. If the printer runs out of ink or something else happens, it'll be able to be like a separate stop motion. One idea is to build in a sensor for the input labels so that when they run out, that'll automatically stop it.
Right.
But all of this, I'm not going to hook it up, but it's got the same kind of little sensor, plugs into all the same connections, drives its power. Oop, I can see my little Arduino Nano I removed.
Yeah, right.
So, but
Cannibalized it.
so for me, this is actually the bigger win of phase dock than for final production, because my desk looks like a tornado.
Right.
I've got 18 different things at once, some of them software, some hardware, some electronics. I could not build this if I had each of these separate on my desk, where, okay, I got to move it out of the way, and I got to pick this up and hope that this wire doesn't pop loose.
Yep.
Ugh. This way I can pick it up, put this down somewhere else, and it's out of the way. I think I have 3 or 4 phase docks at home in various states of project, and it's nice to be able to put it out of the way and know that when I get it back, it's good to go.
It's in the same state. Yeah, and honestly, we told this story before, but honest to goodness, that was the original inspiration for the phase dock. Was, I tell a story of my friend Andre all the time. I know, hey Andre, you're out there. It was the same thing. He had 2 or 3 projects on his desk, and he couldn't move them. And I said, you know what? I bet we can solve that. And that really was the driving factor. But I love the fact that people have now started to see that, yep, you can take it beyond the prototyping and actually either put them into production or use them as the basis for a single board design like you did there. So that's, you're like the whole use case in all directions. That's awesome.
I am definitely a fanatic. I actually wanted to come over here and show a couple of my little phase duct parts. I keep a large tub of many of the clicks and slides, and on many of them, you can actually see where the screws go in.
Yep.
I know that some people have this notion, oh, I don't want to mess them up, I don't want to cut it, I don't want to put a hole in it. Heck no. I cut these up and I reuse them. I even made myself a little box with all the bazillion little parts that you guys come with.
Yep.
So now I've got them all in one spot. It's been super helpful.
Yeah. And I would
didn't think
reiterate that. That is something I always kind of wanted, and that's one of the reasons we're driving to injection molding is we really want people to think of those components as hackable, right?
Yep.
And just dive in with the drill and the Dremel and whatever, and that's exactly what we envisioned.
Yep, it's great for me. I just make sure that I have one of everything in my little thing, because sometimes I'm mounting a little microcontroller that you folks provide a slide for, but sometimes it's a liquid crystal display or anything.
Yeah.
So I'll just find something that fits right.
Yep.
So that's been nice. I didn't think to bring it. I actually 3D printed a holder for scope probes that click into a couple of spots on the back of the phase dock, so my scope probes have a place to sit, and from there I run the wires into the circuit wherever I need them.
Right. And that's another thing that that I would say is, so those are printed ABS. which means you can super glue either PLA or ABS to it very easily. So if you do print your own adapter, it's real easy to quickly and securely put it on there, and then you can just go and do whatever, whatever you wanted to do.
I actually prefer screws. And actually, I know that you folks ship with these longer screws. I actually
Yeah,
ordered some smaller ones.
Uh-huh.
If I have a really tiny part that doesn't
Yeah.
need any clearance, it just digs right in.
Yeah.
I've reused some of these 3 or 4 times.
Yeah, 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 yeah. Screws are good because you can take things off. So it depends on which direction you want to go. Again, just more versatility. Just however you want to hack it. So perfect.
Yep.
Yeah. Well, so that was a really great kind of walkthrough of the whole process. We saw Millard Fillmore, and then the Rosser labeling machine. Um, what else have you got in there? You've done a lot. Two things I see you leveraging really hard. One is 3D printing. You've really kind of tell us about that.
I love 3D printing. I printed my name tag. Everybody here at RBI wears a name tag. I use Shindo. They're kind of prosumer printers.
Yeah.
A little bit higher end. They're fast and reliable. I have been shocked how much I do 3D printing. I print everything. I've done hundreds of designs for a little piece part. Like, why don't you just swing around here? This little piece right here,
Oh,
just
yeah.
for hanging a roll of tape.
Yeah, right.
So I use the command adhesive to
Right,
stick
right.
it on there, and I'll put a piece of tape right there.
Yep.
So it's handy where you need it. Obviously not right now. Everywhere you look around here, you'll find 3D printed doodads.
I have to say, when I first started 3D printing, I was pretty skeptical, but I am astonished at how strong the parts are. And you're right. As long as you can quickly design something, you can solve a problem very, very quickly.
I had never done 3D printing before a year or so ago. I dove in. I learned Fusion 360, which, as far as I'm concerned, is the best software that's ever been created. Fantastic. I know. Chris, you use something else?
Well, you're right.
A SolidWorks guy.
I am a SolidWorks guy, but I have used Fusion as well. But I would just put a shout out there that either package, people should, if they're interested in going down this road of doing some mechanical work, please learn either one of those, some kind of a 3D solid modeler, because when you couple that with a good 3D printer, boy, it really just opens the universe up to you. So I think one of the big things that has helped you succeed is your mastery of Fusion, because you are able to model complex things very quickly and then go to 3D printer. So either way, I would put a shout out for solid modeling. Absolutely, yeah.
Right. Fusion has got a great maker program. I've heard that SolidWorks is coming out with one. Don't know the details, but they're really competent, excellent packages. There's also some free versions, but I could not imagine doing this if I had to outsource design, especially since some things I can actually design and print in 30 minutes
Right.
for a little one-off.
Right, exactly.
Fantastic.
Yeah, yeah. And that's something actually we've talked about and simply haven't had the bandwidth to do to this point is we're going to open source the slides and put some online parametric design software out there so that people can actually quickly and easily design their own slides without having to have software, just by typing in some numbers, so that we can help people kind of a gentle on-ramp into that process. So I love to see, because again, you're not a professional mechanical engineer, however, you're doing really professional level engineering, and I've seen that with my friends here as well. Andre's an EE, but he is got really strong mechanical abilities. My friend Matt is an industrial engineer again. So that ability to design and go to 3D printing has just been really spectacular. And to see it come to fruition there with what you're doing is just amazing. So, and then the other thing you're doing is you're using a lot of that 80-20 extrusion, right?
Oh, I live and die by this stuff. I actually use the 80-20 brand because it seems to be really well supported.
Yeah.
I'm lucky that they're really super slow to ship, but there's a Granger within walking distance of RBI, so I'll actually go walk down there, pick it up, and walk 3/4 of a mile here with the 4-meter long bars over my shoulder to get them back.
That's
So then
awesome.
I'll cut them up with the miter saw. As I tell people, a miter saw is a device that turns aluminum into glitter.
Yep.
It's just incredibly messy. But I do a lot of cutting up of it. These are all parts for pump stack, which we'll see in a little bit. You know, I make a cut list. And one of the things that I created recently, let's say that I've got these 3 pieces. What I normally do, if I need them at a certain length, I'll rough cut them a little longer. I'll square up the end. I'll tape them, then cut them at the right length.
Sure.
It's really common that the exact length isn't as important as them all being the same. But I found that I really struggled with, especially if you get 4 or even 6, to kind of keep them square. So I designed some little 3D printed pieces where I can slide them into the base. Now I know that they are sitting flush. Now I can easily put the tape around them and then go and cut them. So I
Wow.
have these little guys for, you know, the common sizes that I need. It's worked out really well.
Yeah.
It saves me a ton of time.
That's amazing.
It's helpful to have that. I've got I can build 4 or 5 pump stacks, which again we'll see here in a minute. Whenever you're ready for that, Chris.
Yeah, and that's actually what I was going to say is so that's been helpful. We've seen the end product. We've seen some of the ways you've gotten there. So tell us where you're going next.